The universe has always been humanity's greatest mystery, a vast, infinite canvas painted with stars, galaxies, and secrets older than time itself. Since its launch in 2021, the James Webb Space Telescope has been our most powerful tool to unravel that mystery, a technological marvel peering deeper into the cosmos than any instrument before it. Its golden mirrors have captured light from the dawn of creation, revealing the universe's infancy in breathtaking detail. It was built to answer the questions that haunt us. How did the universe begin? What were the first galaxies like? Are we alone? For years, it's delivered jaw-dropping images and groundbreaking data showing us the chaos and beauty of the early cosmos. But now, in a series of observations that have left the world reeling, the James Webb Telescope has uncovered something so shocking, so impossible, that it's forced us to question everything we thought we knew. This isn't just another discovery. This is a moment that has stopped the world in its tracks, a revelation that could rewrite the story of the universe and our place within it. The cosmos isn't what we thought it was, and what Webb has found might just be the evidence that changes everything. It all started with a routine observation in early 2025, a moment that seemed ordinary but would soon turn cosmology upside down. The telescope turned its gaze toward a region known as the cosmic dawn, a time just a few hundred million years after the Big Bang, when the first stars and galaxies were supposed to be forming. Scientists expected to see faint, chaotic clusters of gas and young stars, the primitive building blocks of the universe. But what they saw instead was beyond comprehension. In a field known as Good South, Webb captured images of galaxies that weren't just forming. They were fully formed, massive, structured, and as large as our own Milky Way. These galaxies shone with the brilliance of mature stars, glowing brightly just 200 million years after the Big Bang. In cosmic terms, that's a heartbeat. According to every model, galaxies need billions of years to grow, to coalesce, to stabilize. These shouldn't exist. They're too big, too organized, too perfect. And yet, there they were, staring back through Webb's lens, as if daring us to rethink the rules of the universe. The shock didn't end there. As astronomers dug deeper into the data, they found more anomalies, patterns that defied explanation. In a galaxy cluster known as SMACS 0723, Webb observed something chilling. A series of light points arranged in a grid-like formation, perfectly spaced across millions of light years. Galactic evolution is supposed to be messy, driven by gravity and random collisions, not precision. Yet these light points formed a geometric pattern, a near-perfect hexagon that repeated across multiple images. In another region, a spiral galaxy showed rotational patterns that broke every known model of gravity. Its arms spun too quickly, as if pulled by a force that didn't match any natural phenomenon. The farther Webb looked, the stranger the universe became. Patterns emerged where there should be chaos. Symmetry appeared where randomness should reign. Scientists tried to dismiss it as a glitch, a trick of the data. But the anomalies kept piling up, too many, too consistent, too deliberate to ignore. Then came a discovery that sent shivers through the scientific community. While observing an exoplanet system 1,200 light-years away, known as TOI 715, Webb detected something that shattered every rule of planetary formation. A planet, dubbed TOI 715c, was found orbiting its star at a distance twice that of Pluto from our Sun. This world is 12 times the mass of Jupiter, massive beyond reason, and exists around a star that's only 10 million years old. By all accounts, this planet shouldn't be there. There's no visible protoplanetary disk, no leftover gas or dust to suggest how such a colossal world could form so far out, so quickly. Even more baffling, its atmosphere contains heavy elements, metals that should only form in the cores of stars over billions of years, not in a system this young. Questions began to swirl, each more unsettling than the last. What if this planet didn't form here at all? What if it's a remnant of an older system? A relic of a star that died long ago, somehow transplanted into this new one? Or worse, what if it was placed there deliberately, by a force beyond our understanding? The anomalies kept coming, each one more mind-bending than the last. In a region known as the Hubble Ultra Deep Field, Webb captured an image of a gravitational lens, a phenomenon where a massive object bends the light of a more distant one, creating a distorted arc or ring. But this lens, centered around a galaxy, wasn't just any ring. It was a perfect circle, an unbroken halo of light with such mathematical precision that it defied all odds. Gravitational lenses are rare, but they're never this exact. For this to happen, the alignment between the two galaxies would need to be precise to within a fraction of a degree across billions of light years. An event so statistically improbable, it's essentially impossible. Yet there it was, glowing in Webb's images, a cosmic bullseye that seemed to mock our understanding of space-time. Could this be a hint of a deeper order in the universe, a symmetry we've never noticed before? Or is it something more, a sign that the fabric of the cosmos was shaped by a force we can't comprehend? But the discovery that truly stopped the world came during a deep field scan in a void sector, a region of space thought to be empty, far from any major galaxies. Here, Webb detected something that no one could explain. A series of rhythmic pulses, light fluctuations, too regular to be random, too faint to come from any known star. These weren't the chaotic flickers of a pulsar or the erratic glow of a quasar. They repeated at exact intervals every 11.7 seconds for 48 hours, then vanished. Scientists checked for errors, ran the data through every system they had, but the pattern held. The origin point showed no visible source, no stars, no nebulae, no heat signature, just a steady, deliberate flash in the darkness. The question on everyone's mind is inescapable. What if this is a signal? What if it's a message, not meant to be answered, but simply to be noticed? And if so, who or what was meant to see it? Let's pause and consider what this means. The James Webb Telescope was designed to look into the past, to show us the universe as it was billions of years ago. But in doing so, it's revealed a present we never expected. These discoveries, galaxies too old, planets too large, structures too perfect, signals too precise, aren't just anomalies. They're a direct challenge to everything we know about the universe. The Big Bang, the foundation of modern cosmology, says the universe began 13.8 billion years ago in a chaotic explosion of energy and matter. But if galaxies were already fully formed just 200 million years later, if planets exist that shouldn't, if the cosmos shows signs of deliberate design, then the Big Bang might not be the beginning after all. Some researchers are now suggesting that the universe has a history far older than we imagined, that it might have had cycles, creators, or intelligences that shaped it long before we came along. One of the most radical ideas to emerge from these findings is the concept of cosmic memory. In multiple Webb observations, clusters of galaxies appear to form in patterns that mirror older, more distant formations, as if the universe is echoing itself across time. What if the fabric of space-time isn't just a passive stage, but a medium that remembers? What if dark matter, long thought to be invisible and inert, actually carries information, gravitational imprints of past structures shaping the future of the cosmos? This idea blurs the line between science and philosophy, suggesting that every galaxy, every star, every void might be part of a design far older than we can comprehend. And if that's true, then the patterns Webb is seeing, the grids, the symmetries, the signals, might be the fingerprints of something that came before. But there's another possibility, one that's even more unsettling. In a region far from any visible galaxy, Webb detected a gravitational lensing effect when nothing should be. No stars, no black holes, no visible mass, just a distortion in the light of more distant objects, as if something massive is hiding there. Astronomers have long attributed such effects to dark matter, but this distortion is too strong, too localized, almost like an object with defined edges. Some physicists are now floating a radical idea. What if this isn't dark matter at all, but the remnant of something built, a structure, ancient and invisible, still warping space after billions of years? Could this be the relic of a civilization that spanned the galaxy, leaving behind technology we can't even imagine? Or is it something else? A boundary, a marker, a warning left for anyone who dares to look too far? The James Webb Telescope has always been about discovery, about peeling back the layers of the universe to reveal its secrets. But with these latest findings, it's done something more. It's forced us to confront the possibility that we're not just observers of the cosmos, but participants in a system far older, far more deliberate than we ever imagined. Galaxies that shouldn't exist, planets that defy logic, signals that hint at intelligence. These aren't random noise. They're data points, real and measurable, that challenge the very fabric of our reality. And if the patterns are real, if the signals are deliberate, then we must face the most profound question of all. Are we truly alone? Let's dive deeper into the implications. If these discoveries point to a universe shaped by intelligence, what does that mean for humanity? The idea of cosmic intelligence isn't new, but it's always been speculative, relegated to science fiction or philosophical debates. Now, with Webb's data, it's becoming a serious hypothesis. The rhythmic pulses detected in the void sector aren't just random fluctuations. They're structured, repetitive, and precise, qualities that in any other context we'd associate with a signal. On Earth, we use similar patterns to communicate, to broadcast our presence to the stars. Could this be the universe's version of a beacon? A message sent across eons to whoever is listening? And if it is, what does it say? Is it a greeting, a warning, or something we can't even comprehend? The fully formed galaxies in the cosmic dawn raise even more questions. If the universe was capable of producing massive, structured galaxies just 200 million years after the Big Bang, then our timeline of cosmic evolution is fundamentally flawed. One possibility is that the universe is far older than we think, with cycles of creation and destruction that predate the Big Bang. Another is that some force, natural or otherwise, accelerated the formation of these galaxies, shaping them with a precision we can't explain. The hexagonal light patterns in SMA CS0723 and the perfect gravitational lens in the Hubble ultra-deep field only add to the mystery. These aren't the products of random chance. They suggest a level of order, a design, that challenges the chaotic model of the universe we've held for decades. Then there's the planet Toy 715c, a world that defies every rule of planetary science. Its size, its distance from its star, its heavy element atmosphere, all point to a history that doesn't align with its young host star. Some researchers are now exploring the idea that this planet is a wanderer, a rogue world that drifted into this system from somewhere else. Others are asking whether it could be artificial, a megastructure built by an advanced civilization and placed in orbit for reasons we can't fathom. The idea sounds outlandish, but the data is real, and it demands an explanation. If this planet is a relic of an older cosmos, or worse, a deliberate construct, then the universe is far stranger than we ever imagined. The emotional weight of these discoveries can't be overstated. For centuries, humanity has looked to the stars with a mix of wonder and fear, seeking answers to our biggest questions. Are we alone? What is our place in the cosmos? The James Webb Telescope was supposed to bring us closer to those answers, but instead it's opened a Pandora's box of new mysteries. Each image, each data point, is a reminder of how little we truly know. The galaxies that shouldn't exist, the signals that shouldn't be there, they're not just scientific puzzles. They're existential challenges, forcing us to confront the possibility that the universe isn't just a random collection of stars and planets, but a system with purpose, with meaning, with intelligence. Imagine the moment when the first scientist saw those rhythmic pulses in the void sector. Picture the silence in the control room, the disbelief, as the data was checked and rechecked. This wasn't just another observation, it was a turning point, a moment when the universe revealed something it had kept hidden for billions of years. For the astronomers who witnessed it, it was a mix of awe and dread. Awe at the beauty of the cosmos, at the precision of those pulses glowing in the dark. Dread at the realization that this could be the first sign of something far greater than humanity, something that might not even notice us as it shapes the stars. The public reaction has been just as intense. Across the globe, people are grappling with the implications of these findings. Social media is ablaze with speculation, from theories about ancient civilizations to fears of an impending cosmic reckoning. Some see hope in the data, a sign that we're not alone, that the universe is alive with possibility. Others feel a creeping unease, a sense that we've stumbled onto something we weren't meant to find. The images from Webb, those massive galaxies, that perfect gravitational lens, those eerie pulses, have captured the world's imagination, sparking debates in living rooms, classrooms, and laboratories. This isn't just science, it's a cultural moment, a shared experience that's uniting humanity in wonder and uncertainty. Let's explore the science behind these discoveries in more detail, because the data is what makes this moment so extraordinary. The galaxies in Good South, for example, aren't just large, they're impossibly complex. Spectral analysis shows they contain heavy elements like carbon and oxygen, which should take billions of years to form in the hearts of stars. Yet these galaxies exist in a universe that was barely out of its cradle. One hypothesis is that these galaxies formed in a previous cosmic cycle, a universe that existed before our own. Another is that some unknown process, perhaps a surge of dark energy or an undiscovered particle, accelerated their formation. Whatever the cause, The data is clear. These galaxies are real, and they're forcing us to rethink the timeline of the cosmos. The hexagonal light patterns in SMA CS0723 are equally baffling. In nature, hexagonal patterns are rare but not impossible. Think of honeycombs or basalt columns. But in space, across millions of light years, such precision is unheard of. The light points are evenly spaced, their brightness consistent, their arrangement stable over multiple observations. Some astronomers suggest this could be a natural phenomenon, perhaps a quirk of gravitational lensing, or a rare alignment of stars. But others argue that the pattern is too deliberate, too artificial. If it's not a signal, it's at least a structure, one that hints at a level of cosmic engineering we can't yet comprehend. The gravitational lens in the Hubble Ultra Deep Field is another enigma. Its perfect circular shape requires an alignment so precise that the odds are astronomical, literally. To put it in perspective, the chances of two galaxies aligning this perfectly across billions of light years are less than 1 in a trillion. Yet there it is, a glowing ring that seems to taunt our understanding of probability. Some researchers are exploring whether this could be the result of a cosmic string, a hypothetical defect in space-time left over from the Big Bang. Others wonder if it's evidence of a megastructure, a Dyson sphere, or similar construct built by an advanced civilization. The truth is, we don't know, but the data is undeniable, and it's pushing the boundaries of what we believe is possible. The planet Toi 715c is perhaps the most personal of these discoveries because it forces us to think about worlds beyond our own. Its massive size and distant orbit make it an outlier, but it's the heavy elements in its atmosphere that truly set it apart. These elements, iron, nickel, titanium, require stellar processes that take eons to produce. Yet this planet orbits a star that's barely a cosmic toddler. One theory is that the planet formed elsewhere, perhaps in the core of a dying star, and was ejected into interstellar space before being captured by this young system. Another is that it's not a planet at all, but a constructed object, a relic of a civilization that mastered the art of moving worlds. The idea is speculative, but the data is real, and it's sparking a new wave of research into the origins of planetary systems. The rhythmic pulses in the void sector are the discovery that's captured the most attention, and for good reason. Their regularity, every 11.7 seconds like clockwork, is unlike anything we've seen in nature. Pulsars, the closest analog, emit radiation in bursts, but their timing varies slightly due to stellar dynamics. These pulses, by contrast, are metronomic, unwavering, and they come from a region with no visible source. The absence of a heat signature or electromagnetic noise rules out most natural explanations. Some scientists suggest it could be a new type of astrophysical phenomenon, perhaps a quantum fluctuation in dark matter. But others are bolder, proposing that this is a deliberate signal, a beacon left by an intelligence that knew someone would eventually look. The pulses stopped after 48 hours, but their impact lingers, a haunting reminder that the universe might be trying to tell us something. These discoveries are more than just data points. They're a wake-up call. For decades, we've assumed the universe is a chaotic, indifferent place, governed by physics and chance. But what if it's not? What if the patterns Webb is seeing, the galaxies, the grids, the signals, are evidence of a deeper order, a purpose we've only begun to glimpse? The idea of a designed universe is controversial, but it's no longer fringe. Prominent physicists are now openly discussing the possibility that the cosmos has a history, a memory, or even an intelligence that predates humanity. The implications are staggering. If the universe was shaped by a conscious force, then every star, every planet, every galaxy might be part of a larger system, a cosmic machine with a function we can't yet understand. This brings us to the emotional core of the story. These discoveries aren't just about science, they're about us. They're about what it means to be human in a universe that might not be as empty as we thought. For the first time, we're faced with evidence that suggests we're not alone, that the cosmos might be alive with intelligence, with purpose. It's a thought that fills us with awe, but also with fear. What if we're not ready for the truth? What if the signals we're seeing are a warning, a boundary we're not supposed to cross? Or what if they're an invitation, a chance to join a cosmic community we've only dreamed of? The uncertainty is overwhelming, but it's also exhilarating. This is a moment when humanity stands on the edge of something vast, something profound, and we have the chance to decide what comes next. The James Webb Telescope has given us a gift, a glimpse into a universe that's stranger, more beautiful, and more mysterious than we ever imagined. But with that gift comes a responsibility. We can't ignore what we've seen, the galaxies that shouldn't exist, the planet that defies logic, the signals that hint at intelligence. These are real, measurable, and they demand our attention. Scientists are already planning follow-up observations, using Webb and other telescopes to probe these anomalies further. New missions are being proposed, new theories are being tested, and the global scientific community is buzzing with excitement. But this isn't just a job for scientists. It's a moment for all of us to come together, to share our ideas, our hopes, our fears, and to ask the big questions. What is the universe trying to tell us? What is our place in this cosmic story? As we move forward, one thing is clear. The James Webb Telescope has changed the game. It's shown us that the universe is not a passive backdrop, but a dynamic, evolving system that might be far more connected to us than we ever thought. The discoveries of 2025 are just the beginning. With each new image, each new data point, we're peeling back another layer of the cosmos, revealing truths that are both thrilling and terrifying. The galaxies in Good South, the patterns in SMACS 0723, the planet Toi 715c, the pulses in the void sector. These are not isolated events.